Alright, example 2. Find the vertical asymptotes if they exist by using one-sided limits, graph the function. So for each of these, let's start by graphing it. And let's start by finding the asymptotes. So if I want to know the horizontal asymptote, notice here that the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote has to be y equals 0. The vertical asymptote would be x equals -1, because that would make the denominator 0. Okay, so that's not part of the domain. So let's try to graph this now. So first of all, I've got a horizontal asymptote at y equals 0, and I've got a vertical asymptote at x equals -1. Now let's do a table. So let's pick a point to the right of the vertical asymptote. Let's pick 0. I'm going to plug 0 into this function. I'm going to get 1/2. 0, 1/2. That means this part of the graph would have to look like this. Right? Because it's not going to cross the horizontal asymptote or the vertical asymptote. Now let's try a point to the left of the vertical asymptote. Let's try -2. So if I plug -2 in for x, -2 plus 1 is -1, -1 times 2 is -2. This is going to be -1/2. So that's going to be down here. Okay? Now let's use one-sided limits to describe the vertical asymptote. So this is how this will work. Since we have, let's take the limit of this function as x approaches -1 from the right. That is equal to positive infinity. Also, let's take the limit of f of x as x approaches -1 from the left. That's going to equal -infinity. This right here is telling me, from this information, I can conclude this is how calculus states that there is a horizontal asymptote at, or no, I'm sorry, a vertical asymptote, sorry. There's a vertical asymptote at x equals -1. This, and when this goes to positive or negative infinity, that tells you that there's a vertical asymptote at x equals -1. Okay? Alright, so there's the first example. Let's look at the second example. Second example. Again here, let's see if we can figure out the horizontal asymptote. Horizontal asymptote, notice that the degree of the numerator and denominator is the same. So we've got the leading coefficients, which is 1. So this is going to be y equals 1. Let's look at the vertical asymptote. Okay. The vertical asymptote would be what can I plug in here that would make the denominator equal to 0? Well, when x is equal to 1, or when x is equal to negative 1. So let's do let's draw the horizontal and vertical asymptote. So first of all, the horizontal, y equals 1. X equals negative 1. And x equals 1. Now we just have to test points here. So first of all, let's look at this vertical asymptote. Let's pick a point, an x-coordinate, to the left of it. So let's pick, that's 1, let's pick negative 2. When I plug negative 2 into the function, I'm going to get 4 plus 1 all over 4 minus 1, which would be 5 over 3. So 1 2/3. So that means it's going to be like this. Okay. Let's pick an x point in between the two vertical asymptotes. So let's try 0. So f of 0 would be 1 over negative 1, which is negative 1. So that's going to look like this. Okay. Let's try 1 to the right of this vertical asymptote, which would be 2. So let's try f of 2, which is going to be 5/3 again. So now my graph looks like this. So now use one-sided limits to describe all the vertical asymptotes. Let's start with this one. Okay. So let's do the limit of f of x as x approaches 1 from the right. We can see that that's going towards positive infinity. Let's also try the limit of f of x as x approaches 1 from the left. That's going towards negative infinity. So this tells me that there is a vertical asymptote at x equals 1. Also, I need to do this guy. Do one-sided limits again. So let's do the limit of f of x as x approaches 1 coming from the right. You can see that this is going down towards negative infinity. Here we have the limit of f of x as x is approaching 1 coming from the left. This is going towards positive infinity. So again, this is telling me that there is a vertical asymptote at x equals, oh, this should have been negative 1. Negative 1. Alright, let's look at part C. Okay, part C. Same thing here. We're going to graph it and then describe the one-sided limits, or describe the vertical asymptotes using one-sided limits. So this should be a trig function that you are used to graphing from trig. Okay, so here is 2 cycles of the cotangent function. This obviously repeats forever, so you have vertical asymptotes that go on forever. Okay? So the vertical asymptotes happen at x equals k pi. Okay? Where k is an integer. Okay, so if you forget what an integer is, here is the set of integers. They're all positive whole numbers, all negative whole numbers, and the neutral number here. Okay, so this would be 0 pi. This is 1 pi. This is 2 pi. Out here would be 3 pi. That's where all of the vertical asymptotes are happening at. Okay, so we need to write that as a limit. So let's, using one-sided limits to describe that. So let's do the limit of this function as x approaches k pi. We'll say this is k pi. From the right, that's going to equal, always from the right, that's going to equal positive infinity. And when you have the limit of f of x as x approaches k pi from the left, going this way, that's going to be negative pi. This one-sided limit describes vertical asymptotes at x equals k pi.